Alright, so in this lesson we're going to talk about the electrostatics that we covered at the start of the term. So what we did was we did a little starter to find out the details of the charges, locations and stuff like that of the electrons, protons and neutrons. We found that the protons and neutrons have the same size, but the electrons are much smaller. And this is indicative of the fact that what happens is electrons can move around, protons do not really move around, they stay where they are because they're really big and heavy, and there's a strong force between the two of these. But more importantly, it's the charge that we're more concerned about. 1.6 times 10 to the minus 19. Positive for proton, negative for electron. Okay, so electrostatics, study of electric charge that is not moving. And we know what an atom looks like. You have your protons and neutrons in the center, electrons around the outside, and it's these electrons that get transferred when objects rub together or when you do conduction or induction and stuff like that. An atom will be neutral if you have the same number of electrons as you do protons. So there's two charges, a negative charge if you have gained electrons, and a positive charge if you have lost electrons. Only the electrons are moving, I have to stress that. Electrons are the only things that are being gained or lost. No protons, no neutrons, they stay where they are. And the Coulomb is the SI unit of charge. The symbol is C, and the charge of one electron is 1.6 times 10 to the minus 19. So if you want to know how many electrons make 1 Coulomb, you take the 1 Coulomb and you can divide it by the charge of an electron. That will tell you 6.25 times 10 to the 18. That's a lot of electrons. The rule we used was Q equals NE. Q, this was the total charge, so total charge, yeah? And this is the number of electrons, number of electrons. And this one over here is just the charge of an electron, which is 1.6 times 10 to the minus 19. 1.6 is fine. You don't have to be specific. 1.60 or 1.602. This is enough. Okay, so we did some more practice stuff, and then I discussed electric charge being quantized with you. So that means that they can only exist in multiples of 1.6 times 10 to the minus 19. So you can double it, you can triple it, quadruple it, times by 100. As long as it is a multiple of this, then we know how many electrons will be in it. Because one electron has a charge of 1.6. This number here, times that, 1.6. Not less. So you can't have a number in between. You can't have 2.1 or 2.2 because 2 electrons is double of 1.6. Okay, 3.2. So that means 1.6, 2 times 1.6, 3 times 1.6, all things are fine, but random other numbers are not fine. Okay, so moving on with this lesson, we've figured out how to charge objects. We charge by conduction or friction, which is by touching. We also charge by polarizing and induction, which is from a distance, without touching. Polarizing is the first step of induction, and I'll explain that. So, beginning with this, friction is simply when you rub two things together, electrons get transferred from one thing to another, from one that's more positive into the one that can be more negative, or I should say the other way around, more negative into the more positive. There is a triboelectric series that tells you where it would go. It will go from here downwards into something like that. But you do not need to know about this triboelectric series. You will not be questioned about it or asked anything about this. We just need to know the term friction is charging by rubbing. Okay, that's all we need to know about. By collision is the same idea. When these neutral objects collide with each other, electrons can get knocked off and switched from one electron, from one atom to another atom, like this in a helicopter blade when it hits the air particles at high speed. And you can also get a balloon sticking to a wall with the same idea. You get your balloon, rub it against your clothes or your hair, and you attach it to the wall, and you'll see that your balloon might pick up electrons from you, or from your hair or whatever. And when you bring it close to the wall, the electrons in the wall that were over here will be repelled. They will run away, leaving just the protons behind, and that is actually polarizing. Leaving the protons behind, then it'll stick to the wall. Okay. Induction is when you charge something without touching. So you get two uncharged spheres. If you bring a positive rod next to it, whatever electrons that were on the right hand side, because there will be electrons everywhere, it will be something like this. There will be something like that. Same on the left one. They're scattered about, evenly spread out. The electrons will come across to this side. They will be attracted to the positive charge on this rod. They're attracted to it and they can come across. And then what we do is we take these two and we separate them. We just move them apart. We will move these two apart. Now the electrons are stuck and they will move around, spread out away from each other. Protons are also stuck, so nothing can move. That has been officially charged. Great. So conduction, induction, polarization. And just to remind you, polarizing, actually this part is polarizing. Polarizing. This part right here. When they are being separated. Once they've been polarized, you switch them. And what if you wanted to, you can ground it, you can add a ground, and you can get more electrons coming up. They will come up here. That will also bring this back to a neutral charge and whatnot. Okay, so did some examples with you in class. We'll cover examples in another video. We are agreed that like charges will repel and opposite charges will attract. This is basic stuff that you already know. In a conductor, charges are free to move. They can move around easily. But in an insulator, they are kind of stuck in place. They can't really move around. And we covered these examples in class as well. So I'm not going to go through this in this video. It'll be too long. Going back into further detail for conduction, this is induction, sorry. This is another thing that can happen. You can take one ball. You bring the rod again close to the ball, and these things will polarize. So they have swapped around. So the electrons have been repelled to this side, and the protons are staying on this side. And then you can do the same thing if you have a positive rod. The electrons get attracted, and the protons disappear. Well, not disappear, but they stay on that side. Okay, this is induction. And then you do that, and you can also touch it, as I was saying, to the ground. So this person is going to get a nasty electric shock, but you can touch it, the electrons can leave. And once they've left, that means the sphere itself is stuck with that charge. Okay, so we had a neutral thing, took a balloon, negatively charged balloon, electrons were repelled, polarized. All the electrons are on the right hand side now. So when you touch it, the electrons will go into your leg, or your arm I should say, all the way down, and that leaves just the protons left. Which means we now have a positively charged sphere simply by bringing a negatively charged balloon to it. Okay, same thing will happen if you bring a positively charged balloon. It will do the exact same thing, except now that we have the electrons on the left, protons on the right. When you touch it, electrons from your body will go towards the protons that were here, because there were protons here. And you now have a negatively charged sphere. An electroscope is something that we use to detect charge as well. You have a charged rod. If you bring it close to a metal plate, if we have electrons in here all along, they will come up to the top of the plate and spread out here, leaving only positive charges. Because these are positive, this leaf and this leaf will repel. That's how you know there is a charge on your object. Okay, so we've covered induction. We've covered everything. I think that is everything for this lesson. Conservation of charge, also important. You most likely know this already. Charge cannot be created or destroyed, only transferred, a bit like the conservation of energy. So the total charge in an isolated system is always conserved. So you will, if you have 10 protons and 10 electrons, you will end with 10 protons and 10 electrons. If they go to the ground, then the ground has 1,000,000 plus 10 electrons. But those electrons do not disappear. They actually just get transferred. Okay, great.